Welcome to the explainer. Before an attacker ever launches a real attack, they've probably already walked through your digital front door. They've been mapping everything out. Today, we're diving into how they do it through a critical phase of hacking known as enumeration.
So how does it happen? It's not about brute force, it's about intelligence gathering. In this explainer, we're going to see just how a potential intruder can meticulously chart out your entire network, long before you have any idea they're even there.
The best way to think about this is like a burglar casing a house before a break-in. They aren't smashing windows yet. No, they're methodically walking the perimeter, checking every single door, every window, and actively jiggling the handles to see what's locked and what's left wide open.
All right, here's our game plan. We'll kick things off by defining what enumeration really is. Then, we'll get into the weeds of how attackers probe common systems like Windows, scan key protocols, and map out directories. And most importantly, we'll wrap up with how you can actually defend against all this.
Okay, so first up, what's the goal here? What is on an attacker's shopping list when they start this whole process? What kind of information is so valuable it's worth all this effort?
Well, take a look. This isn't just a random grab bag. It's a systematic effort to build a complete, detailed blueprint of your network's assets. Every little piece, from a username to a routing table, is another piece of the puzzle. Once they have this map, an attacker knows exactly where the weak spots are and can plan a precise, effective attack.
To really see how this plays out, let's look at one of the most common targets out there: Windows systems. Specifically, we're going to look at a protocol called NetBIS, which is often a goldmine for attackers.
Now, NetBIS might sound like some old-school legacy tech, and, well, it kind of is, but it's still active on a surprising number of networks. For an attacker who knows what they're doing, this simple naming service is an absolute treasure trove of information.
So what do they get? They can map out the entire domain structure, they get a list of all the computers on the network, and here's the kicker, they can discover sensitive shared folders that might not be secured properly.
And this isn't some secret complex technique. We're talking about readily available tools. Some are even built right into Windows, like NBStat and NetView. These commands can automate the whole discovery process, making it incredibly fast and efficient for an intruder.
But it's not just about Windows file shares. Attackers are also going to be methodically scanning other common protocols, especially those used for network management and email. They're always looking for weak configurations to exploit.
Right, let's talk about SNMP. This protocol is absolutely essential for IT admins. It's how they monitor routers, switches, servers, you name it. But if it's misconfigured, it becomes an open book, giving an intruder the exact same visibility as your own team. And the classic security failure here is painfully simple, not changing the default passwords. In SNMP, these are called community strings. An attacker just has to try common defaults, like public. And if it works, they can walk away with a detailed map of your entire network infrastructure.
It's a similar story with your email server. An attacker can literally have a conversation with it. They use these simple commands to figure out which email addresses are valid. And why would they do that? To build a perfect, clean list of employees to target in their next big phishing attack.
Okay, now let's get into two extremely powerful techniques. With these, we're moving beyond just finding devices. We're talking about mapping out your entire organization's directory of people and the very layout of the network itself.
The difference here is absolutely crucial. LDAP enumeration targets services like Active Directory to map out the people, the usernames, the departments, the whole org chart. DNS enumeration, on the other hand, maps the machines, the host names, and their IP addresses. A smart attacker, of course, is going to use both to get the full picture.
And this quote nails the DNS threat. A zone transfer is basically like walking up to a DNS server and saying, "Hey, can I have a copy of your entire address book?" A properly secured server will say no, but a misconfigured one? It'll just hand over a complete list of all its internal records.
Okay, we've seen the threats, we've looked at the techniques. Now, for what really matters. How do you build your defenses to stop this from happening?
Look, there's no single magic trick here. A solid defense is all about having layers. It comes down to basic security hygiene. Restrict access, turn off old protocols you don't need, and please, change every single default password. It's about building a strong security posture from the ground up.
When it comes to DNS, your defense is twofold. First, you lock down who can ask for information by restricting those zone transfers. Second, you protect the integrity of the data you do share by using technologies like DNSSEC to cryptographically sign it.
And, sometimes the simplest moves are the most effective. Just putting a basic firewall rule in place to block those legacy ports like TCP 139 and 445 from the internet can shut down a huge number of these net BIOS and SMB enumeration attempts cold.
But you've got to remember, none of this is a set-it-and-forget-it solution. Security is a process, not a product you can just buy. It requires constant vigilance, ongoing auditing, and staying ahead of the attackers, who are always changing their game.
And in the end, it really all boils down to this one fundamental question. You think you know what's on your network, but do you really know what an outsider, an attacker, can see? Closing that visibility gap, that's the first and most critical step toward building real, lasting security.